Welcome to AWS EBS Service and Architecture. In this section, we'll take a deep dive into EBS. We'll understand what EBS is, what its features are, how to use EBS volumes, how it's architected, and how to create an EBS volume and assign it to our EC2 instance. The EBS volume is a block storage service from Amazon. It provides a persistent storage for your EC2 instances, and we could use these EBS volumes on our EC2 instances for its operating system, to install applications, or to create home directories, or whatever purpose you deem necessary on your EC2 instances. The data that you copy onto EBS is automatically replicated within the AZ, and this promises high availability and durability for your data. EBS also has support for snapshots. Snapshots are typically used to take backups of your EBS volumes. So what are EBS volumes? EBS volumes are persistent block storage that we can use with our EC2 instances. If you want to use a disk for operating system, for applications, for users' home directories, or project folders, or database applications, we could use EBS volumes with that. This basically acts like a local storage that is attached to the EC2 instances, and these are raw disks, so you need to create file systems on top of it. And the data that you copy onto EBS volumes are automatically replicated within the same AZ. This provides high availability and durability for your data. EBS volumes also has support for snapshots. So that means you could use this feature to back up the data that's on your EBS volumes, and these snapshots are saved safely on an S3 bucket. We'll see how the snapshot feature works in a second. There are essentially two different types of EBS volumes that Amazon provides. The first one is the magnetic disk, or HDD, that we saw in the previous section, or the SSD disks, or the solid state devices. So some of the features of EBS volumes. The first feature we want to talk about is called provisioned IOPS. So provisioned IOPS essentially guarantee high performance IO or input-output operations from our devices. They provide consistent and fast response time for our applications. So if you have applications like database, NoSQL applications that require consistent high and fast response times, so you need to enable provisioned IOPS for your EC2 instances. Provisioned IOPS is an additional cost on top of the EBS volumes. And we talked about two different types of disks Amazon provides. The first one is called general purpose SSDs, and they have 99.999 or 5 nines of availability. They are best suited for boot volumes and small databases. The second type of SSD is called provisioned IOPS. So essentially they basically take the SSD and add provisioned IOPS on top of it, and they offer consistent and low latency performance. The latency is in single digit for our applications, and these provisioned IOPS SSDs are designed for high intensive, high input output operations applications, or raw NoSQL databases, application servers that require high input output operations. Provisioned IOPS is highly recommended. The last type of EBS volumes that they provision is called magnetic volumes. So these are, the cost of this magnetic disks is the lowest that you can get in Amazon, but they offer lower performance than the other two disks, the provisioned IOPS disk and general purpose SSD. So we talked about snapshot support. A snapshot essentially lets you take a point-in-time copy of your EBS volumes. So that means as of that moment, as of that time, essentially it copies the entire contents of the EBS volumes and keeps it into an S3 bucket. And the snapshots are stored in S3 buckets. You can take as many snapshots as you want of your EBS volumes. The other benefit of snapshot is, let's say you start, in this case, if you look at the diagram, if you start with a 10 gigabyte of EBS volume, 10 GB volume, but then after a few weeks or few months you run out of room, the best way of increasing that size is to take a snapshot, create a larger volume. In this case, I'm creating a 100 GB volume with that snapshot. And then when you present this volume to the EC2 instance, this 100 GB volume has all the data that was originally on this 10 GB volume. And then the host can start using the new volume. So this snapshot is the best way of increasing the disk size of our EBS volumes. In addition, we can also use the RAID methodology that we learned in the previous classes, in the previous section. So we can stripe or mirror disks that are provisioned to EC2 instances. So in this case, I have provisioned or attached 3 EBS volumes to my instance, and I'm using RAID technology and then present it to the EC2 instance. So in this case, let's say I have a 10 GB volume, there are 3 10 GB volumes. I can then stripe them and then present it a larger logical volume to my EC2 instance. So the smallest volume that you can create in EBS is 1 GB, and the largest you can create is 16 TB. This is a single EBS volumes. Again, this depends on the disk type that you have chosen. If you choose a SSD volumes, you can go up to 16 TB. If you choose a magnetic disk, the higher limit is 1 TB. In addition, there is support for encryption. So if you want to encrypt your data at rest, so this is the best option to use in that case. Amazon makes it really easy for you to use encryption. They manage all the encryption keys. Or if you prefer to use your own keys, you could use another service that Amazon has called Key Management Service. And this service allows you to use your own encryption keys. EBS can be attached to one instance at a time only. This is an important concept. So this is very similar to a USB disk when you attach it to one laptop or one computer at a time. And that EBS volume is private to your instance. That means that data is visible only to your instance. If you want to look at the monitoring tools that are provided, you could use the CloudWatch service that Amazon provides to look at the I/O rate, the read latency, write latency, the throughput of your disks, and the queue length that we talked in the previous section. Usage patterns where we could use the disk, pretty much wherever the disks are required, relational databases. Again, like we mentioned in the previous slide, provisioned SSDs are recommended for large relational databases. For web applications, for web application servers, for NoSQL databases that require low latency and consistently high performance from their disks, the EBS volumes are recommended. For file servers and for test and development environments. Let's talk about the EBS architecture. In this diagram, I have two instances, instance A and instance B, and I provisioned 3 EBS volumes. The first one goes to the instance A, and instance B has two EBS volumes, 2 and 3. And when you take a snapshot, like we mentioned, the snapshot gets copied to S3 bucket. And I can choose to use these EBS volumes as individual disks on instance B, or I could use the RAID technology that we discussed to stripe them or to mirror between those two EBS volumes. Again, the EBS volumes are like network attached block storage for your EC2 instances. So when you create an EBS volumes, these are the steps, or this is the workflow that you go through. Initially, when you create a disk, the status of the disk becomes pending, and after a few minutes, when the disk is created, the status changes to available. When the disk is available, you have two options. You can attach it to an EC2 instance, or you can delete that EBS volumes. When you attach to that EC2 instance, the status changes to attached. That means you cannot attach it to any other EC2 instance. And when you're done with using that EBS volume, you can detach that volume, and the status again becomes available. And when you delete that instance, the status goes into pending, and then finally the status is changed to deleted. So this is the workflow of EBS volume creation to deletion. So in summary, we learned at high level what EBS volumes are, what the features are, the major features of EBS. We learned the usage patterns of EBS. We learned the architecture of EBS volumes, and we learn the different states the EBS volume goes through, the different the workflow of an EBS volumes.